Hello, this is video number 74. Welcome. This is about rational exponents. It's our second video on rational exponents. And this video kind of wraps up this unit on exponents. Here we go. We want to review a couple things. First, uh, you have to explain why x to the fourth equals the fourth root of x. So we have to be able to explain why this makes sense. Okay, well, it makes sense because if you multiply x to the 1/4 times itself 4 times, you will get x to the 1/4 plus 1/4 plus 1/4 plus 1/4, which is 1. That means if you multiply x to the 1/4 by itself 4 times, you get x. But that is exactly what the cube, or the fourth root of x means. So we see that x to the 1/4 has to be the same as the fourth root of x. The number you multiply by itself to get 4 times to get x. Okay, so we can play this game with any actually exponent like this. Why does x to the 1/2 equal square root of x? Well, because when I multiply x to the 1/2 times itself 2 times, I get x to the 1/2 times x to the 1/2 equals x to the 1, because 1/2 plus 1/2 equals 1. But that's the job of square root. If we multiply a number by itself and get x, that number must be the square root of x. Okay, all right, so we just have to kind of make sense of what these mean. All right, we've done this also. So we want to convert the following into exponential notation. All right, you got to remember that if there's no index here, it's not a 1, it's a 2, the square root, okay? So x, or 5 is the power, 2 is the root. Okay, well, if we want to include one little extra step, we could break this up like this. This is x to the 5th to the 1/2, or x to the 5/2. All right, we can skip that little step here if we want. If we recognize that 6 is going to go in the numerator because that's the power, and 4 is going to go in the denominator because that's the root. So this would be m to the 6/4. And we can simplify 6/4. This is actually equal to m to the 3/2. Same thing here. This is the root. This one is the exponent. So this would be c to the 7/3 power. 7/3 doesn't reduce, so we'll leave it like that. Okay, so this was kind of old stuff. All right, today in class we started something new. We started multiplying expressions like these, and our job was to simplify them. Okay, well, the way we're going to simplify this is convert them to exponential notation. Again, remember, if there's no index here, it's assumed to be a 2 for square root. So this is x to the 1/2, this is x to the 1/3, and this would be x to the 1/4. Now that it's in exponential notation, we can just add the exponents. This would be x to the 1/2 plus 1/3 plus 1/4, which if you do that is 13/12. So to do this, it's helpful to have a calculator that does fractions. All right, now we're supposed to write our answer in radical form because that's kind of like what we started with. So remember, 12 is the root, 13 is the power. So this is going to be x to the 13th and the 12th root of that. Okay, so that's the answer there. All right, on this one, let's convert this to exponential notation. This is x to the 2/5 times x to the 3/4. Okay, so again, we can add the exponents. And it turns out that 2/5 plus 3/4 is 23/20. All right, so I used the calculator for that. So that's x to the 23 over 20. All right, now rewrite this in radical form. It's going to be x to the 23rd. So 23rd is the power, and 20 is the root. So the 20th root of x to the 23. Crazy, but it's not so bad once you get used to it. All right, two last problems. We can do division also. We just subtract exponents. Okay, so let's rewrite it with fractions. So the first one in the numerator is going to be x to the 11th fourths, and the denominator x to the 5 halves, not 5 over 1, 5 halves. The index is 2. Okay, if we subtract those, 11 fourths minus 5 halves, that gives us 1 fourth. And if we write that in radical notation, that's the fourth root of x. Okay, done. This one's no problem. We're going to multiply in the numerator and then divide by the denominator. Okay, so this is going to be x to the 5/3 times x to the 7/6 all over x to the 1/3. So we got to do, to simplify this, we got to do 5/3 plus 7/6 minus 1/3. Okay, if you do all that, you get x to the 8/6 is actually equal to x to the 4/3. Then radical notation, that's x to the 4th and the third root of that. Wow. Okay, so the key to these problems are not bad at all. Just rewrite them with exponents, and you guys are pretty good at that. Then you're going to be adding exponents if you're multiplying powers, subtracting exponents if you're dividing powers. Okay, time for the journal assignment. There you go, there are 4 problems like these. So you're going to simplify the following. So first you're going to change them to exponents, and then either add the exponents or subtract them, whichever the case is appropriate, and then convert it back to radical form. All right, just don't forget that if it's missing an index, it's a square root. It's 2, so this is the square root of x to the square root of x to the 7th there. Okay, this is the square root of x to the 9th. All right, good luck.